Hello everyone. In this video we will be discussing about the stack concept in data structure. So very first, stack is a linear data structure where the insertion and deletion of elements can be done from only one end. For example, whenever we talk about the stack, you can take the example of any array also you can take. So just a normal array it is. But here the one thing we need to remember that insertion and deletion of elements can be done from only one end. Okay, so this is the representation of stack. Before getting in this detailed discussion, let me tell you what is the principle we follow in the stack. So the principle is last in first out. It means that the element which is inserted last here will be deleted right. For example, 10, 20, 30, 40, 50, 60 like that inserted. The element which is going to be deleted first is 60, last in first out. Okay, so in another way we can say philo also, first in last out. The element which is inserted first should be deleted last. So let us get into the details. So there are certain operations in a stack. So first one is push operation, second one pop operation, and the third one is display operation. So these three names you need to remember. Push, the process of insertion of elements into a stack is known as push. Whatever the elements we are getting stored in stack, that process we call it as push, and deleting the elements from the stack we call it as pop. Okay, so now display operation is nothing but from last to first we can display the elements. So major operations are only push operation and the second one is pop operation. Okay, so now, so I'm showing a small example of push operation here. Let us take the example of any stack. Initially it is mentioned with top equals to -1. We are taking one support of one variable which is initialized with -1. Why this top is very important in stack is very essential, this variable. Okay, let us assume we have taken one particular array or stack you call it here. So look at the indexes 0, 1, 2, 3, 4. So initially the stack is empty, no element is available in the stack. So now the element I am inserting is 10. I am inserting push operation I am performing. The element here we are inserting is 10. Okay, so next the element which we are inserting is 20, next one 30, next one 40, next one 50. You just look at the reference I have mentioned here with that variable top. Initially it is -1. Initially it is what? -1. Okay, why it is kept to -1 is, so whenever we are trying to insert the element, the top value is getting incremented by 1. Means when the first element is inserted, it should be stored at which index? 0 index, right? So that index I want to represent with the help of top. Next element is inserted 20. You know where it is inserted? The index 1. Again the top value is getting incremented to represent the index of recently inserted element. Now where the 20 is inserted at the index 1, that particular index I am getting stored in top. Variable name is top. One more element is stored here, 30. Which index it is? 2. The which index it is? 2. And here from here again I am incrementing the top value by 1. So the top value is now 2, which is the index of recently inserted element. Here the recently inserted element is 30. Now again 40 is inserted. Again the top value gets incremented to 3. Why? Because 3 is the index of the 40 where we are storing. Okay. Now again 50 is inserted. The top value is 4. So at each insertion of element, the top value is getting incremented by 1. Why we are doing this is only to represent where the recently inserted element is stored. The index we are representing here. Okay, so the operation what I am discussing here is push operation, the insertion of elements into the stack. First 10 is inserted, next 20, next 30, next 40, next 50. Now I am going to talk about pop operation, and do remember in pop operation the element, the principle of stack, what is that? LIFO, last in first out. Now the element which is inserted last should be deleted first. Now I am going to perform pop operation. So hope you are understood here. Push operation, here element is inserting, before inserting the element I am incrementing the top value by 1 in order to represent the index of recently inserted element. Now I am coming to the next operation, which is pop. For the before example, now all after inserting all the elements, the top is all the elements are the top is at fourth index. Okay. Now I am deleting 50. After deleting 50, which element is at the top? 40. What is its index? 3. So in order to represent that, top value is decremented by 1 here. Means during insertion, the top value gets incremented by 1. During deletion, during pop operation, top value gets decremented by 1. So after 40 is deleted, now the 30 is the topmost element. In order to represent that, top value is again decrementing by 1. So the top comes to second index. Next again 30 is deleted, top value is now coming to down, that index is 1. Now again 20 is also deleted, top coming to 0. The 10 also deleted, again top value becomes minus 1. You observe here, initially top value is minus 1, initially when the stack is empty. At each insertion of element, top value is getting incremented. After 5 elements are stored here, top value is becoming 4, which is the index of topmost element. And similarly, in push operation, the top value is getting incremented one by one at each deletion operation. After deletion of all the elements, the top value is now minus 1. Okay, we can call it a stack underflow. If the stack is full, we can call it a stack overflow representation. Okay, so now from here, let me go to the programming example. So very first push operation I am writing. So for entering, push operation is nothing but inserting the element. For that I need one element, right? Int n. That is what I am taking. Here the element what I am taking is n. So printf enter n. Okay. So now scanf percentage %t ampersand n. Now this is the n value what I am going to store. In the diagram, you just see here this 10 what I am trying to insert. Now initially top value is minus 1. Okay. So that I will write before the main function here. Those should be written in global variable so that any function can access that. Int top equals to minus 1, and I need one array, right, with size 10 I am giving, and the variable max I am taking it as 10, which is the size of the array. Okay, these three are needed for me, that's why I am taking. Now n value is there, so what I have to do is just in push operation, top should be incremented by 1, and in a of, look here, a of top I am writing. Why? Because first time you are inserting, initially your top value is minus 1. Now when you are trying to insert for the first time, top value is becoming 0. It means the n value what you are going to store in the a of top, which is nothing but a of 0. You see here in the diagram also the same thing I have represented. The first element what I have inserted in the index 0, which is the value of top. So always while inserting, I will always write a of top. The top will be the index of recently the element where you are going to store. A of that index you are going to store the element. That's why top is very important here while push operation or deletion operation in stack, entire stack. Top value gets incremented by 1 during insertion or push operation. Top value gets decremented by 1 during each pop operation. So before that, before inserting the element, I can check one condition. When the stack is full, we cannot insert the element. That's why we can take the help of top. If top is max minus 1, what is the max value I have given here? 10. Max minus 1 is nothing but 9. When the top reaches the 9th index, it means your array is full, your stack is full. That's why you cannot insert. You can print one message here. Printf cannot insert because stack is full. Otherwise, you can store the element by incrementing the top value by 1. Now this is just the push operation of stack. Very simple. Just you are taking the n value, that value you are trying to store in the stack. Okay, while storing you are incrementing the top value so that to represent the index of now where the element you are going to store. A of top is the reference we are taking. Top reference is very important here. Okay, before that I kept one if condition only to mention that if top is full we cannot insert the element. That's why. Okay, this is push operation. Now let me come to the pop operation. In the pop operation, what I told you, top should be decremented at each pop operation. The only step what you need to write is top minus minus. That's it. But let us add some conditions. If top equals to minus 1, if top equals to minus 1, where the top is minus 1, you just look at the diagram. Where the top is minus 1, empty. If the top is empty, can you delete the element? No, na. That's what. One condition I am putting. If top equals to minus 1, I am just printing the message. Cannot delete. Okay. So now, if top is not empty, then we should delete it. For deletion, only one step is needed, top minus minus. That's it. Okay. So just have a look once again. Push operation. For push insertion operation, that's why you need n value to store. First, before storing that value into the stack, just checking whether it is full or not. If it is full, then you are printing the message. Otherwise, just you are incrementing the top. By taking the reference of top, you are storing the n value. During deletion, you are just decrementing the top value. But one more condition you are adding. If top is minus 1, if stack is empty, you cannot delete that message you are displaying. And the third one, display. From where to where you need to display the elements in stack. You observe carefully here this PPT where I am showing the elements of a stack. Always you just, if one element is there, top from one element is there, top to 0. If two elements are there, one top to 0 index. If three elements are there, top to 0 index. If four elements are there, top value to top index to 0 index. If five elements are there, top index to 0 index. Always top index to 0 index you need to display the elements in a stack. Reverse order you need to display. Not 10, 20, 30, 40, 50. Instead 50, 40, 30, 20, 10. Like that you need to display. That for that what I am doing here is I am going to write a for loop int I. That for loop is going to start from top, is going to end at the index 0. As you are coming from top to bottom, I value is decrementing. So printf percentage %d backslash t comma a of I. This is display operation of stack. Okay. So push, pop, display. So these are the operations we are doing. So in order to make it as menu driven program, let me take out one variable here where I am writing while of 1. Okay. I want to execute this. That's why I have to have the main function. That's why I'm writing this. Otherwise, the push function is this, pop function is this, and the display function is this. This is enough to understand how the stack works. Okay. I want to execute this. That's why I'm adding some messages here. So what are the options you have? Printf, I'm asking enter one option for push function. In the similar way I am putting printf enter, let me add here, enter 2 for pop operation, pop function or pop operation, anything you can write, and printf enter 3 for display operation. Okay, fine. Now after that I will be asking like enter your choice. So based upon this message, by looking at this message, the user is going to enter the choice. So for that I am using scanf for reading the choice. Where in which variable I am storing? ch. For that I have taken the variable ch. And while of 1 I have taken. Why? Because I want to repeatedly display this message until the user wants to exit from here. So that's why I kept a while of -1. So basing upon the choice given by the user, now I am going to use the switch cases. If your case 1, I mean it is a push operation, case 1, then just call a push function, then break. If your option is 2, call pop function and apply break. If your option is 3, case 3, then call the function display break. If none of the other than 1, 2, 3, you can go for default case where you are going to exit. There is a function called exit with one value we have to write so that we can coming out of this particular program. Okay. So now let me check what I have done here. While of 1 I have written until I want to exit from this, the same message will be printed. Okay, so based upon the choice, first option push function will be called. If I am selecting the second option, pop function will be called. If I am selecting the third option, display function will be called. Okay, other than 1 2 3. So you are going to coming out of this code. Okay, here I can add one more message here, printf enter other option for exit. Okay, so it will go to default case, then you will come out of this program. So now let me execute this code once. Look here, it is asking enter 1 for push function, 2 for pop function, 3 for display. So now I am entering first option. First option is nothing but push function, means I have to enter the value. 23 is the first value I have given. This will be stored in the stack. Look here, why I am getting this repeatedly? Why? Because in the main function I have written while of 1. In the main function what I have written here, while of 1. That's why we are getting. For that purpose only I have written while of 1. Now again it is asking for the options. Again I will select first option. The second element what I am going to store in the stack is 45. Second element. Now again I am selecting the first option. The element what I am going to store is 56. Now look at the elements, how many elements I have entered. First one is 23, second element is 45, and the third element is 56. Now let me check them whether they are stored or not. For checking, we have to select the third option. Third. Look here, 56, thereafter 45, thereafter 23 is getting displayed. Why it is getting from last to first? You know that. In a stack, the elements are going to be displayed from last to first. Now if I am selecting, for example, option 2, what is going to happen? Enter 2 for option pop function. The element is to be deleted. Which element among them is going to be deleted? The element which is inserted last. 56 is inserted last. Na? That is going to be deleted first. Okay, let me check whether I have deleted or not. Operation is done here, 2 selected. Again the option is showing. For checking, I am selecting the option 3. Look here, this time 45, 23 is there. 65 is not there. What is the third element? What is it? 56 is not there. 56 got deleted. If I select the option 2 for one more time, 45 also going to be deleted. Now let me check. Now only 23 is left. Now again a first option is selected. 67 this time. Now the elements are 23, 67. Topmost element is 67. You want to check, then option 3, 67. Like this. Now like this we have kept on entering the elements. I want to come out of this program. Then I will select other than 1 2 3 option. Then let me select 5 option. Now look, I am exit from this program. This is how the stack concept works. Okay, mainly you focus on the functions. Just n value read. If top equals to -1, why? Because we cannot insert the element if top is full, if stack is full. Okay, otherwise increment the top, and using that reference you store the n value. Pop is for deletion. So if empty stack is there, we cannot delete anything. That's why top equals to -1. We are putting that condition and related message. Otherwise in pop we are just going to top -1. In insert top ++, in deletion top -1. And I am displaying the elements from top index to 0 index. That's what. This is about stack. Hope you understood what stack is. Okay. Now here just have a look one more time. Stack concept. Okay, where we are following the last in first out. Okay, operations push to pop display operations. This is push operation. Inserting element, top value gets incremented at each insertion, and the top value gets decremented at each deletion. Hope you understood what stack is. Thank you guys.